We're group 15, and we are going to be doing the independent t-test and the one-way ANOVA on SPSS. And the purpose of these features is to measure one group and a secondary group, and to see if the mean for the first group is statistically significant in relation to the other group. And it's important to note that the two groups are independently measured, as well as the other software programs that we have used in class that have similar features are Excel as well as Tableau. And so we're going to start off with the independent t-test.
Alright, so the independent t-test, the purpose of the independent t-test is to compare the means of two independent groups in order to determine whether there is a statistical evidence that the associated population means are significantly different. So for the data, we will be getting the data from Excel, and we'll be changing the file type to Excel and clicking on the 152 project and open. Alright, and so for the sheet, we will go to the independent t-test and click OK. Alright, and in data view here we have the no college and college IQ, and we'll switch over to variable view and add the IQ score. Alright, and then we will switch over to data view again and copy the no college and paste it over under IQ score, and then also copy college IQ right under the IQ score as well. Alright, and then we will switch over to variable view and add group. Alright, and then we no longer need the no college, so we will clear that, and also as well as college IQ. And then we will manually enter 1 for no college and 2 for college. And then we will start with 2 for college. And we will switch over to variable view and go under values and add 1 for no college and then 2 for college. And then add as well, and then click OK. Right, and then we'll switch over to data view, and then you can see here that in place of the 1s and 2s, there is no college and college. Alright, and then now we are ready to run the data. Right, so we will go over to Analyze, Compare Means, and hit Independent Samples t-test. And for IQ score, it will be under Test Variable, and the group will be under Grouping Variable. And to define the groups, we will have group 1 as 1 and group 2 as 2, and hit Continue, and then we will hit OK. Alright, so here we have the analysis, the t-test, independent t-test. For if p is less than 0.05, there is a significant difference. And if you look over at the means, the college grads have a higher IQ, have higher IQ scores than non-college graduates. And for the confidence interval of the difference, it means that the range of differences that likely contain the real mean and difference in the IQ scores for a population. And that concludes the independent t-test, and we will be moving on over to the one-way ANOVA. Okay, now we'll do one-way ANOVA. I'm gonna open a new. Okay. So in the meantime, while it's opening, I will explain what one-way ANOVA is. One-way ANOVA is used to determine whether there are statistically significant differences between the means of two or more independent groups. We already have our data saved in Excel, so I will import it into SPSS. To do that, I'll click Open. In the file types at the bottom, I will select Excel. And my data is saved as data for 152 projects. And select that and open. All right, I have the read Excel file. I have everything, so I don't need to do any changes, or I don't need to uncheck anything. I just hit click. Okay, here I have my data. I have three different variables: classroom only, online only, blended learning. These are the three. I'm interested in to know the significance between different learning types. So here I'm gonna go ahead and I have to actually have I have to change the three columns into, since it is since I'm interested in to learn about different groups. SPS won't let me run analysis with the three different variables. So I'm going to go to a variable view. Before I do that, I'm going to go back to data view and select copy and paste all data under online only in the first column. I do the same thing for blended learning. Copy and paste in the first column. And I'll delete this too. I don't need this. Go back to variable view. Here in the classrooms, in this variable, I will change it to, since I'm interested in to know the learning type, I'll just type learning type. And in the second row, I will just put group. Go back to data view. Here in the data view, I'll just enter value manually. For classroom only, the value is 1, and online only will be 2, and blended learning will be 3. So here I have 30 data. Go back to variable view. I have to change the values, the group value. That's a categorical variable. So 1 is for classroom only. Click add. 2, online only. Add value number 3, and label is blended. Add, and I'll click OK. Gonna go back to data view to see the values. Okay, I'm just gonna go run the analysis right now. Analyze, compare means, one-way ANOVA. Learning type I'll be moving learning type into dependent list, and group will be in factor. on the right corner, right side, I'll click on post hoc, Tukey, click continue, and options. Here I have descriptive, and that's all I need for now. Continue, and I'll click OK. All right, here I see my output. I see the result. I have the first box descriptive, the second one is ANOVA, and here the multiple comparison window. We can see here the comparison list and the classroom only compared with online only and blended learning. The p-value, we look at the p-value here, 0.986, which is very high, so it's not significantly statistically significant, but classroom only in blended learning is 0.033, which is less than 0.05. So this is statistically significant. There is a difference between the classroom and blended learning only. And then the second one online was classroom. The third one, I want us to look at the blended and classroom only. Again, 0.033. There is a significant difference between the blended learning and classroom only. And that would be it. Thank you.